Hey folks, welcome back to another video. Today we're looking at question 859, body strings. The way we'll be approaching this problem is actually dividing up the strings that are given to us in two ways. The first way of actually dividing it is that if the strings are equal, and if the strings are not equal. So if strings are not equal. The reason why we need to divide them up into these two cases is because if the strings are in fact equal, the only way this problem should return true is if at least one character occurs more than once. So for example, if the strings that are given to you are ABA and ABA, right? The strings are wait, actually this is a bad example. So ABA and ABC. So these strings are equal, but the thing is you cannot like replace any two letters which would give you the same strings. But in this case, ABA and ABA, they are equal, but because there's at least like one letter that occurs more than once, you can actually return true. So these are the two test cases that we need to handle under the strings that are equal. And under the strings that are not equal, what we need to do is we need to keep a track of how many characters are not the same. And if it's two, well and good. But the thing is, even if they're just two characters, we need to like swap them and see if the letters will actually be the same. It's a pretty simple problem, but it's just a lot of typing. So let's get started. So let's start with the base cases, right? Actually, let me erase this comment. So the base case is what? They actually need to be of equal length, right? So if S dot length, actually I wonder if we can make this, let's call it S and T. Okay, so if S dot length is not equal to T dot length, basically that means they're different lengths altogether, and even if you swap characters, they won't really be the same. So if it is, you would return false. Nice. So that's the base case. If S dot equals T, if they are the same, basically what you need is you need to count the number of characters. So in that case, what you do is that S, let's call it SL, so S letters is new and equals 26. And the reason why we take 26 to be the size is because we know that only lowercase letters will be used. And since we know that lowercase letters are only 26, that's the reason why we initialize that int array to 26. Okay. If S dot equals T, what you need to do is for int I equals 0, I less than S dot length. I should have saved this somewhere, as in like stored it in a variable so that it would be easier instead of calling S dot length every single time. Minor detail, let's just do that. So S dot length itself would be equal to S dot length, and here it can just be S at this point. L. Okay, so we have all of the basics that we need to get last syntax of length. Right. So after that setup is done, what we need to do is basically increment the number of letters. So how do we do that? So we do S. If they're equal, I wonder if you actually need it for both. So S dot L of S dot character at I minus A. So basically what this is doing is that if you've gone through the ASCII table, let me just write this here. the ASCII table. This basically represents all of the letters and characters in the English language to a number in hexadecimal, in decimal, and in binary. So all of the values from A to Z, they increment with a value of 1. So I think the value is close to like 72 or things like that. I'm not sure. It could be. So the value of Z would be 72 plus 26. 72 plus 26, I think. Yeah. Right? So basically, what you're trying to do here is that when you're subtracting A, you're subtracting the base, like the base values. So basically the value that A starts off with. So if the character is actually A, so it will be SL of 0, as in the first letter in the alphabet would be incremented by 1. This is commonly used in all the other coding questions as well. So I would recommend going through the ASCII table and understanding how it's used with characters. All right, so once we have this, we ask, all right, so they have to be, you increment, and then what you do is you say return at least one greater than, at least one letter greater than one letter, if you want to be really. So basically what are we doing here? Basically what we're doing is we're saying, hey, like collect all of the characters that we have, count them, and if it is actually greater than 1, as in like those things can be swapped, it's true. So basically this is a pretty simple helper method that you initialize. It would be an int a, let's say for int I equals 0, I less than 26, because we know the given size will always be constant. And then if I is greater than 1, return true. Let's see, return false. Right. I'm sure there are more efficient ways of doing this. For example, you could basically put all of the letters in a given set. And since a hash set just keeps a track of all of the unique values, you would just have to check whether the size of the set is the same as the length of the string. That would have, I think it would have taken, I guess we could have avoided like this method altogether if we went through that route, but there's something to think about. All right, so the next test case, like the cases that we need to handle, is if the strings are in fact not equal. So in this case, what we'll do is we'll keep a track of the indexes that are off. Let's call them off indexes. Is equal to new array list. Nice. Okay, once we have that set up, okay, nice. All right. So for int I equals 0, I less than s, set a, yes, L, I plus plus. So if, what do we do here? If s dot character at I, if it is not equal to t dot character at I, what we do is we just insert that index of indexes dot add, yeah, I, okay, cool. All right, so once that is done, you need to check two things. If off indexes is not equal to 2, as in we need exactly 2 indexes to be true. If it is not equal to true, as in like swapping these two characters won't really give us the solution, you would just return false. The other thing that you need to check is if s dot character at, so yeah, s dot character at auth indexes dot get 0. Okay, so this needs to be equal to this right here. So what are we checking here? We're checking that if the indexes, we know that 2 indexes are off, right? Sorry, the size here. So basically, if the size is not equal to 2, you return false. And then s dot character add. What you're checking here is that, okay, we're taking the 2 indexes that are off, and we're checking if you actually swap them, they will be equal. And then you get this. Okay. This would be, yeah, I think this should be fine, T, and then this should be S. Awesome. So if they are the same, you would return true. Even after all these, if it hasn't reached any of the points that we have reached, that means it is a problem and we need to return false. Right, let me check if this closes off here, this closes off here, this parenthesis closes off here, this parenthesis closes off here, so we don't need this. Do we need that? Okay, wait, let's try running this. Yeah, we definitely need that one. Okay, all right, let's try again. Oh, right. Oh, wait. Of course. Always a problem here. Now. Maybe. Hopefully. Let's try again. Where is this? So this closes this off. This closes this off. Oh, I have too many. Maybe? No. Okay, let's try again. All right, so the first few test cases pass. All right, so everything else passes as well. All right, I think even though this question is easy, it's unnecessarily complicated. I'm sure there are easier ways of doing this. If you have any creative ideas, please let me know in the comments below. So let's talk about the space and the time complexity of the entire solution. The time complexity of the entire solution is of n, since we are going through each and every letter of the strings that are given to us. And the space complexity should be of 1, but in worst case scenarios, it could be of n. Since we are using an additional data structure here, array list, but if it's just 2 characters that you're adding, like 2 indexes that you're adding, it should be constant of 1. But if all of the indexes are different, the size of this would grow, and then the space would be of n. Awesome. If you have any questions about the way I solved it, please let me know in the comments below. Please don't forget to subscribe and like the video. I would really appreciate that. It definitely keeps me motivated to make more videos. Thanks so much. I'll see you folks in the next video. Peace.